Vision now your entire screen. Can you see now?
Not now. It will take a while. When you press present now and select your screen, then it may take few seconds, maybe 20-30 seconds, sometimes 1 minute, depends upon the size of the file. But anyway, means when we press present now, we will see 3 buttons. Out of those 3, we have to select one, sir. Madam. And now it is coming. Now the screen is coming.
See, just see, is it coming now?
Yes, yes, madam. It is very much visible.
Very good. Thank you, sir.
Your title is GGBS in Cement and Concrete for Sustainable and Environmental Friendly. Yes, madam.
So I thank all for being here, and it is indeed a big privilege for us. So the topic today for Rajasthan Technical University Kota is Green Technology and Sustainable Engineering. And we are going to talk about ground granulated blast furnace slag in cement and concrete, the sustainable development part and environment part for this same. So with me, I have my colleague, Mr. Neelam Kumar Sawant. He is the head of Technical Services West Zone. And my name is Lopamudra Sengupta. I am heading Technical Services for JSW Cement All India operation. So about the group first, briefly we will cover the JSW Steel. Close the door. JSW Steel, 18 million ton steel capacity. JSW Energy is 4,531 megawatt. This is last year's figure. We are the largest manufacturer of Portland slag cement with a capacity of 14 million ton per annum. And we have got also dedicated mines in northern part of the country where we are planning to set up unit, but not now, but later during down the line. We are into JSW infrastructure in ports and with terminals with capacity of 70 million ton per annum. 2019, we have also launched paint. The paint are launched in southern part of the country and west. So we go on to the vision and the core values of the group. Vision is global recognition for quality and efficiency while nurturing the society. Mission is supporting India's growth in core economic sector with speed and innovation, and core values are transparency, strive for excellence, and passion for learning. So what are the various products JSW have which are, green, environment friendly and has got very low carbon footprint? So first is Portland slag cement, which is conforming to IS 455. Second is another variant of Portland slag cement, that is Concrete HD, that is also conforming to IS 455. Portland composite cement, this is conforming to IS 16415, this is a composite cement. Screen slag, IS 383. And we are manufacturing, we are actually utilizing the slag which is coming out of the blast furnace, and that can also be used as a sand replacement. So we all know, especially northern part of country and also in western part of country, sand is a big problem. Even south it has started. So getting river sand, it is practically impossible, and we should not also get it because there is a lot of implication to taking out of sand from the riverbed. It leads to the change of direction of the river, and it changes the topography of that area, not to say it spoils our mother nature. So we have got a very good alternative, which is screen slag, and that has been allowed in IS 383-2016, which can be used as a replacement of sand. Both it can be used in RCC work and PCC works. And you can go up to 100% replacement. Though the IS code is talking about 25% or 50% replacement, 50%, we can go up to 100% replacement with this screen slag. Then is OPC 53 grade ordinary Portland cement conforming to IS 269. And last but not the least, we are having ground granulated blast furnace slag, which comes out of the furnace. This is ground to a very fine particle size, and this is called GGBS. So the chemical compositions of slag as per IS 12089 and IS 16714. So we can see it's a non-metallic product. It consists of silicates and aluminosilicates of lime developed simultaneously with iron in the blast furnace, obtained by rapidly chilling or quenching with water or steam in air. Silica percentage is 27 to 32. The best part is this slag which is there, it is as good as, it is equal to hydraulic cement because of the calcium oxide, the lime content which is there, which is approximately 30 to 40%. If we compare it with fly ash, a slag is compared with fly ash, you will see that the calcium oxide percentage is less than 3, whereas in GGBS, it is in the range of 30 to 40%. Along with that are alumina, iron, magnesia, and the glass content is 85% minimum. The JSW slag GGBS glass content is between 90 to 97.5%. So you can see the microscopic examination of the glassy nature of GGBS particle. Highly reactive, highly siliceous, and also having very good amount of calcium oxide. Because it is a product of an industrial byproduct, it is a controlled byproduct, what happens? The steel which comes, obviously it goes through a very stringent process, and the slag which also comes out is having a very, very high level of quality control and is of superior quality. There is no source to point source variation. It will be same throughout the period of the year. The ore source is, iron ore source is fixed. So this is confirming to IS 16714. This is a green product. CII and IGBC has given the GGBS a certification of Green Pro certification. Also, we have got Environment Product Declaration, which is there. This involves, conservation of the natural resource because it has been made from industrial byproduct, which is, if not utilized, would have created a lot of problem in, in the earth's crust, because then it would have been dumped, it would not have been utilized. So this can be used as a partial replacement of OPC cement in concrete production at ready-mix concrete batching plant and side batching plant through high efficient mixture. Utilization of GGBS will give high strength, chemical resistance, maximum durability, along with reduction of the heat of hydration. So we will be going into the manufacturing process of the ground granulated blast furnace slag, and I will be requesting Mr. Neelam Kumar Sawant to take through this, and I will again join when the relevant section comes. So you do it from here.
Yeah, good afternoon, everybody. Good afternoon, delegates also. So we will see on the screen, this is the manufacturing process of GGBS with the vertical roller mill and the roller press. So definitely the vertical roller press machine is actually installed vertically, and some of the rollers, they are used for the grinding the raw material, that is GBFS, that is glass blast furnace slag. And it also consists one of the table, and the roller is rotated by the electrical motor and by the mechanical press. This all the particles are ground to the final particle, that is slag. The second one is we are observing, that is roller press. It is an advanced grinding machine nowadays which is available, and it is having some advantages. Definitely we are saving the energy, electrical energy, as well as the diesel energy, and it is having high efficiency. Also, there is a less noise, and definitely the uniform particle size distribution of the slag can be obtained. So this is the one of the picture you are watching over here on the right hand side. That is a vertical roller press, and on the left hand side, that is a horizontal depth of roller press machine. These are installed in our grinding units. One of the grinding unit is located in Maharashtra. We will see these are the GGBS and the fly ash. Both are the cementitious product. It can be called as a mineral admixtures. Nowadays we are using in plenty of these things, and GGBS is having the IS code of 16714 as previously stated, and fly ash is having the IS code about 3812. These are the basically substances which are chemically manufactured. As you know, in the morning first session, there was a session taken from the Kota thermal power. They have described fly ash. Now we are more concentrated about the GGBS. So it is obtained by quenching the molten iron slag that you have seen in the previous slide. It is a byproduct of the steel, and definitely this blast furnace slag is now quenched with the jet of water, and then it is cooled down, and again it is ground down to a fine powder. So that is called as the GGBS or GGBFS, that is ground granulated blast furnace slag. The second one is flash, or it can be called as a flue ash, and definitely it is obtained by the pulverization of the any burning of any coal or any rice ash like that, and that coal combustion product that is composed of the particulates that is from fine particles, these are assured, and definitely this can be added as a mineral admixtures for the replacement of the OPC in concrete as well as in cement. So you can see on the bottom side one of the Portland cement OPC, the microscopic picture is there, then the GGBS in the center, and the flash is spherical or like that sizes we are observing. So these are the one of the particle size distributions of GGBS, Portland cement as well as flash particles. We will see the GGBS versus flash comparison. The chemical composition, as ma'am Lopamudra told, this GGBS is having calcium more than 90 to 95% in our JSW product. So we will see calcium oxide in a normal cement clinker, 100% OPC, 62% is the CaO, that is calcium oxide, but as well as GGBS is concerned, it is about 40, then silica content is about 35, then aluminum oxide 14%, then the magnesium oxide that is 8%, and ferrous also 0.5%. These are the comparative is there as a table. We can observe the oxides content of 100% OPC as well as PSC as well as GGBS. So GGBS is having high silica content as well as calcium also there, or lime is also there. That's why it is having extra cementitious property which can enhance the further gain of concrete as well as cement strength. Why the GGBS is important and it is utilized in the cement production as well as in concrete, we will see. This is the chemical reaction. All we know, whenever water is added in OPC cement powder, it forms some CHH gel, that is calcium silicate hydrate gel in the primary reaction. This reaction is composed, or it is acted within 1 day to 3 days or 7 days. So GGBS has an added advantage over the OPC as well as PPC because it increases the durability criteria. Previously, we were observing that there were concrete about M20 grade, M30, M35 was the rare one. But nowadays, from last decade, so many skyscrapers are there. Many infrastructure projects are going on all over the India. So definitely the high strength as well as the durability criteria is they both are coming into consideration. Because I will give you one example. In Mumbai, there are metro railways projects are going on where the contractor has to give the durability criteria. The lifespan of that metro or the structure should be 120 years. So to achieve that durability, we should have some additional or replacement to the OPC, the GGBS, because GGBS not only enhances the compressive strength of the concrete or the cement, but it also adds durability. So whenever this CHH, that is calcium silicate hydrate gel, is formed, some of the calcium is still there inside the concrete formation, and that prone to environmental attack, see this calcium hydroxide. And if I am going to add slag, that is GGBS, in my concrete proportion or in my cement, if it is PSC cement, which is having mixture of OPC plus this slag content, then definitely this slag enhances and it come into consideration in the secondary reaction, and it acts with the calcium hydroxide, and again it forms a CHH gel. So definitely after 3 days, the another secondary reaction up to the 28 days of concrete, it is happening in the secondary reaction, and it gives double CHH gel, which enhances the complete bonding of coarse aggregate, fine aggregate, and the cement particle and water, as well as the chemical admixture. And this gives the additional durability, additional strength. You can see on the bottom, suppose I'm casting a concrete or making the concrete. So definitely after 3 days, you can see this is the one of the microscopic picture. So many pores are there. And after 7 days, as the concrete gets a strength or it dries, definitely it contracts. And whatever the pores are there, those will be evolved and it will be dense and the pores will be decreased. But after 28 days, whatever the remaining pores are there, that space will be occupied by this secondary CSH gel and the GGBS particles. And definitely because of the double hydration, it leads to the less porosity or reduction in the porosity in the concrete. And definitely if we are going to do any chlorine penetration test, that is chloride penetration test, RCPT, it is called as rapid chloride penetration test. Definitely the concrete which is cast with the help of OPC and the concrete which is cast by the OPC plus GGBS mixture or with the purely PSC, definitely that concrete is having less porosity we have observed. And this is also studied in IIT also. That's why that is the reason most of the GC, general construction in the infrastructure companies, they are suggesting PSC for the foundation purpose as well as pile cap and piling purpose. We will see why GGB is also important in reinforced concrete, cement concrete. As I have mentioned, whenever there is a PSC concrete, it gives a less cracking. If I'm using 100% OPC, there will be a lot of heat of hydration. So initial strength gain within the 3 to 7 days will be much more, but there will be leading to the less cracks, superficial cracks and internal cracks also. But I'm using PSC concrete, definitely there will be initially 3 to 7 days less heat of hydration, and after 3 to 7 days gradual strength gaining will be there, and it results to the less cracking. Definitely it gives the improves concrete properties, that is the cement particles will be dispersed evenly, than the particle size distribution or particle packing between coarse aggregate, fine aggregate will be good in the primary reactions also and the secondary reaction. So complete dense matrix of the concrete will be achieved. And definitely it gives improved resistance to acid, chemical contents, chlorides, sulfates also, which are present in the water, if it is a groundwater structure or it is in a foundation structure or it is a seashore jetty. You can observe on the left hand side, this is one of the reinforcement bar is there, which is in red color and it is rusted. And if you see the concrete cover, so many dots, black dots are there, that is called as a porosity. So this is the electromicrograph we have achieved with the concrete which is casted with the OPC, and you can see more pores are there. Whereas if I'm using PSC cement in my concrete or the mixture of OPC plus GGBS in my concrete, definitely these pores will be decreased to the about 10 to 15%. It will be decreased down, and it improves the ultimate compressive strength as well as flexural strength of the concrete. Then maximum reduction in the heat of hydration because of the GGBS addition. It gives a high impermeability because less number of voids and porosity is there, and it also gives the resistance to chemical attack. You can see whenever the concrete is cast with the help of OPC 100%, after 3 to 4 years of span, if you see any pillar or the RCC column which is present in the stilt area of any residential building, it shows some vertical cracks in the surface of the body. And that does it mean that this reinforcement steel bar is catching some of the water from the environment through this porosity, and definitely the rust will be there. Whenever rusting is there, it is electric process, and definitely this bar will give the some tensile forces in the concrete surface on the concrete cover also. And we know concrete is best in compressive strength but weak in tension. So definitely the spalling of the concrete on the surface area and the cover area will be there, and definitely this rusting will be much more, and the load carrying capacity of the structural member will be reduced. And if I am using, instead of OPC, some content will be replaced by the GGBS, this porosity will be reduced down, and definitely your RCC bar will be in intact position. So resistance to chemical attacks will be there, and this is the main very good advantage of GGBS. We will see advantages. It is a green product, as ma'am also told, it is a CI approved green product, and it is eco-friendly product, cementitious, and it is having high resistance to chlorides and sulfates, reduction of the heat of hydration, improved ultimate strength. I will explain about ultimate strength. We know, suppose I'm going to cast the concrete of M20 on site, then definitely the concrete mix design will be done with the target mean strength, that is called as a TEMS, and that is FCK plus 1.65 times of standard deviation. So suppose I am going to do the M20 grade of concrete, and the ultimate strength or the targeted mean strength should be 26 or 27 like that. So in case of that, we should have ultimate strength after 28 days also. If I'm going to use OPC in my concrete after 28 days or within 1 month, the reaction of the OPC 100% will be there, and there will not be any further growth of concrete strength. And if I'm using GGBS, due to the secondary action, after 28 days, there will be 56 days, then the 1 year 365 up to 365 days. This concrete strength will be enhanced, it will be increased about 10 to 18%. And depending upon your workmanship and quality control at site also, but minimum 10% to 18% we can achieve. And definitely, if I am designing M20 grade of concrete, the TMS is about 27, and 27 into about 10 to 18% achievement will be there in the ultimate strength. Particle packing effect will be good, improved resistance to corrosion, as well as the water impermeability will be higher. GGBS advantages over the flash. We will compare the flash with the GGBS. Slag, you know, it is a byproduct of steel and blast furnace slag product, and flash is generally, it is having silica content about 55%, but flash is having less hydrophobic properties or cementitious property as compared to slag. So on the basis of replacement, definitely as per the IS code, flash in the OPC can be replaced up to 15 to 35% as per the IS 1489. But as far as GGPS is concerned, the trials are also done, very much research also done. So in OPC, if I'm going to replace 25 to 70% as per the IS 455, it is allowed. And it depends upon your workmanship, quality control, and the target mean strength. So on the basis of concrete performance, we can see the concrete containing with the GGBS cement is having high ultimate strength than that of 100% Portland or OPC cement, and that concrete which is also made with the flash. So flash based concrete is having RCPT as compared to weak, but as compared to GGBS concrete, RCPT value is low, so it is water penetration is very less in that GGBS made concrete. And in the last this May month also, we have received a permission from the IRC, Indian Road Congress, to replace OPC cement somehow 20 to 30% with GGBS while casting the pavement concrete or PQC. So that is pavement quality concrete, and it is having less crackings on the surface also. So less heat of radiation, definitely less superficial surface cracks will be there. So GGBS having some advantages over the flash. So we can go definitely for the option of GGBS. We can see over here concrete compressive strength as well as the flexural strength development. Whenever I am casting M40 of concrete with water cement ratio about 0.32. We will see these are the researches we have done in IIT Mumbai also, and also in our lab, concrete lab. So if I'm taking OPC, it requires 450 kilogram per meter cube for the casting of M40. So after 28 days, 56 days, and 90 days, the target mean strength for the M40 definitely it is achieving 48.4, and after 90 days it is about hardly gain of 2 to 3 MPa. If I am doing the combination of OPC by partial replacement of 21% with the flash, we can see the 28 days about less 47.5 as compared to the pure OPC, and after 90 days it is 51.5. And if I am using replacement of OPC by 40% of GGBS, this strength is as equal to the whatever OPC, that is 48.9 MPa at the 28 days level, and after 56 days it is increased about 55.6, that is 4 to 5 MPa increase, and after 90 days also it is 61 MPa, means drastic 9 to 10 MPa is the additional strength I am getting if I am replacing OPC with GGBS 40%. And if it is a company made product which is already blended at the company side, that is OPC plus JGBS already made, that is called as a Portland slag cement. Definitely it is a controlled quality product. Definite this after 20 days we are achieving the desired 48 MPa strength, and after 90 days we are getting nearly about 62 to 63 MPa. So you can see the difference. If I am going to cast M40 of concrete with control water cement ratio 0.32, it gives about 51 MPa, and if I am using PSC or the blending of OPC plus GGBS, it gives nearly 61 to 62 MPa. Means you are getting over here 10 to 11 MPa more. So this is definitely will give the additional strength as well as durability for your concrete. So on the right hand side also you can see over here, these are the flexural strength. As far as flexural strength is also concerned, there is an enhancement in the flexural strength. You can see over there, PSC based concrete always shows higher strength beyond the 28 days. This is a graph we have charted. That was previous the example for M40. This is the example for M25 as well as M35. Why we are showing these graphs? Because generally there is a tendency from M20 to M40. These are the commonly used concrete grades in India. So concrete always shows the highest strength after 28 days whenever the PSC based concrete is considered. Heat of hydration. Somebody may ask how much heat of hydration will be there when I am using OPC as well as PSC or the PPC cement. So you can see over here, these are the third-party reports we have done. And after 3 days, about 274 is the kilojoules per kilogram of heat is evolved in pure OPC. And if I'm replacing this OPC with fly ash, somehow the heat of hydration is reduced about 219. And after PSC, it is drastically reduced down about 25, reduced down to 25%. If you compare 275 and this is 67. So naturally, after 7 days also, this is 850 as compared to 225. That is about 25% is the heat only evolved. So definitely PSC cement is very much good. And it is also tested in NCCBM, Ballargarh, that is in Haryana side. And this is a proven track record. And definitely you can observe heat of hydration is very less as compared to the OPC. This is the same thing what we have observed in the thing. If I'm casting any concrete with the 100% of OPC, there will be ingress of carbon dioxide from the environment and water also, chlorides, then the sulfates, oxygen and H2O, which will deteriorate your reinforcement steel and corrode it. But whenever I am using GGBS replacement, then definitely chloride and penetration, whatever is the thing, the Coulomb's value are mentioned in the table. These are the studies we have done, and as per the ASTM it is done, and definitely you will be getting good resistance to this ingress of the external enemies, which should not deteriorate your reinforcement steel as well as the concrete. Chloride migration test. This is actually very much important whenever we are casting and doing the work of offshores. Majority, this is the on the bottom side, you can see this is one of the prestigious project in Mumbai which is going on, that is called as a Mumbai Trans-Harbour Link project. And there for the casting of piles as well as pile cap as well as the jetty and the abutment and pier of that bridges, the third party on the GC general concern, they have specifically told you should go for the blending of OPC as well as slag, that is GGBS, or you go for the 100% PSC. So this is the project specification you can observe. So this is, you can see the migration coefficient is less than 2. Whenever concrete quality it is there less than 2, the concrete quality is very good, and it should be 2 to 8, then it is good. But this, whatever the migration values are all mentioned in this table, and we are getting the results which are actually less than 2 in case of GGBS replacement, about 60% in M45 grade of pile casting as well as cap for these projects. So these are the proven tracks. Water impermeability, definitely these are the major concern wherever the RCC consultants are suggesting for the contractors as well as the builders and infrastructure companies. So water impermeability, abrasion resistance should be there. So if I'm using cement and slag, and this is the water binder ratio, you can see cement about 60% and 40% replacement, and a combination 50-50 percentage, then 40-60 and 30-70. Water binding ratio is 0.34 we are keeping. And you can see the durability testing, abrasion resistance, as well as water absorption. So these are good whenever we are doing the OPC replacement with 50%. Suppose I am manufacturing 50 kilogram of any cement bag. In that, 50% replacement of GGBS is there. That will be called as a PSC. In that case, abrasion resistance as well as water absorption will be much more. So this is the one of the combination you can see over here. These are the studies we have done in IIT Bombay. Accelerated carbonation test. This is also definitely this is important whenever the concrete surface and deterioration is concerned, because we want the durability as compared to the concrete strength. So carbonation depth is measured generally for the quality of concrete. So if I am using the mix OPC and GGBS, if you see OPC 100%, no GGBS is there. After 28 days, this is the 15 mm carbonation is there, and after 56 days it is 11.5. These are the studies I have done. And if I am using 50% of replacement of OPC with GGBS, so after 28 days the carbonation depth is about 12 mm, and after 56 days when the concrete is getting contracted, or it is the pores are now filling up and the concrete is gaining the strength after 56 days with the help of secondary reaction of GGBS. So this carbonation depth is about 5 mm which is observed. So we can see these are the studies whenever the ratio is about 60-40 or 50-50. This GGBS plays the important role for the opposition of this carbonation depth. So this is also another advantages for the durability point of view. Corrosion resistance that I have already discussed, with the help of OPC, any concrete is there diffusivity about 44.7 centimeters square per gram. But if I am using about 50-50 or 45-55, that is a replacement of PSC. So it is about 4.10. So it is drastically reduced to 10% as compared to the OPC. So definitely your reinforcement steel will be in intact position. So PSC based cement or the OPC and GGBS combination will lead to increase in the electric resistivity of the concrete, and thus reduces the chloride diffusivity ions from the outside, and it gives some resistance to the corrosion of reinforcement steel in the concrete, and definitely there will be long life of the structure. Alkali aggregate reaction. This is another phenomenon which is generally happening in concrete. Whenever the critical amount of such type of reactive aggregates are there in fine aggregate and the coarse aggregate, if there is some critical amount of alkali presence is there, then definitely sufficient gel is formed, and it is called as a attringite. And this attringite phenomenon is very much disruptive, or it is harmful to your concrete surface, and it bulges, it expands, and the cracking is generally observed. You can see on the right hand side, this is a concrete girder is there. You can see on the surface some of the signs of this bulging, that is called as the entry-joint formation. You can also observe in some of the canal lining RCC purdis. So there also you can see this alkali reaction is coming out whenever the concrete is formed. Whenever OPC is this is harmful for the concrete, and whenever I am using OPC and GGBS, that is OPC 40% and the GGBS 60% replacement, this attringent will not be formed. And if I am having OPC 100%, the attringent will form because of this alkali aggregate reaction. As we have mentioned earlier, this PSC is the only product which is manufactured in India first time by JSW, and definitely this is the first green cement company, and the certificate is in front of you. There's Green Pro certification from the CII, and definitely this is for the broad of the product, that is Portland slag cement. This is a complete factory product, as well as GGBS, that is glass granulated blast furnace slag. So we are having both the products available in India. You can see environmental product declaration over here, because each and every company has to EPD declaration. So these are the, on the left hand side you can see PSC bag is there, and these are the details of our EPD declaration and registration number. On the right hand side, you can see for the GGBS, this is a 100% GGBS powder in this 50 kilogram of baggage. This is the outlook of our bag. As I have stated, PSC cement is conforming to the IS 455 and GGBS is conforming with the IS 16714. Both are the green products. We can see this is all about our product, but we will now throw a light on green business practices. Nowadays, all of the companies, they are focusing on the green business practices because there are some of the environmental norms from the central government, as we cannot use 100% of limestone for the production of the OPC or your cement. So you have to retain some of the things and limestone for the future generations. So we have to go for the replacement. So companies Ecovision is there offering the green products to our customers time to time. Not only the green products, but okay, while producing any cement, lot of dust is there, and definitely pollution, air pollution will be there, and lot of resources are also utilized, oil as well as energy and water also. So our aim is this: while producing this PSC, definitely these products are the use of natural resources and energy is less, and due to the PSC we are generating less CO2 also. So definitely this implies or this reduces the environmental impact because of this our operations consistently for the energy efficiency as well as product mix design. We will see while quarrying, before taking the raw material for the manufacture of our cement, limestone is also utilized. So we are having controlled blasting nearby our plants, and while blasting we are minimizing the dust, noise, fly rock and ground vibration by any other means, mechanical means. And whatever the topsoil is there nearby our plant location, we have already cultivated, and horticulture is also there. It's a green belt, so that is also required so that greenery and the O2 emission should be there. Previously high-speed diesel oil is used for the manufacturing of this, giving the energy for manufacturing of this PSC cement or cement manufacturing companies. But there are some environmental impacts, so we are now replacing 20% of HS high-speed diesel with some coke and other things, and so that the energy is reduced. Whenever to counteract the air pollution and the dusting, also roadside sprinklers are also installed in nearby our plant area, and definitely we are consistently optimizing the quality of the plant feed material by reducing the energy as well as controlling the noise, dust, and definitely water conservation is also there, because whatever the rainwater is there, we are also doing the rainwater harvesting in our plant area and nearby areas and villages, so that this water will be recirculated and again reutilized. You will see this is from this slide whatever the utilization of the alternative raw material which are using for the producing of cement. About 45% chemical gypsum is used nowadays in our JSW PSC cement manufacturing process, because the gypsum is available both in natural format as well as in chemical gypsum. So natural gypsum is very rarely it is used, and it is also at the base of, it is generally found at the base of sea. But chemical gypsum we are using to conserve the natural gypsum. So about 45% we are replacing. Pet coke is utilized for the pyro processing. We are reducing our HSD, other fuels also. 100% of replacement of iron ore with the flue dust. So iron ore also we are replacing by this flue dust because it is also the industrial waste coming out from our steel companies, and this is a raw material which is utilized in our cement production. And 100% petropolymer fuel PPF is utilized instead of high-speed diesel, and for the lighting up process for the kiln and roto machines. You can see over here in a graphical format, in our company, while producing GGBS as well as PSC cement, limestone consumption, when in 2012 about 1157 was the tons of cementitious material was produced, and nowadays about we have drastically reduced the limestone consumption for the producing of PSC. So about 66% reduction is there, definitely serving the nature. Gypsum, I have mentioned the chemical gypsum we are using. So gypsum consumption for the ton of cement production, it is also drastically reduced from 0.05 to 0.02. It is 61%. Then the coal, which is utilized for the fuel while production of the cement, it is about 74% reduction. And laterite is one of the stone which is generally a raw material utilized for the production of cement. So it is also we are conserving about 67% by replacement of GGBS. You can see we are having all the 6 plants in our India. Those are the energy efficiency. So you can see from the graph, previously in the year of 2014, about 731 kilocalories per kilogram of clinker production, this heat was evolved, but nowadays it is drastically reduced by 3 to 4%. And electrical energy is also reduced by 19% because we are using alternative resources of energies. Water is important for the production of cement because there are the dry process and the wet process for the cement manufacturing. So you can see from these graphs, so specific water consumption for the process cooling, you can see in the year of 2012, we were consuming about 0.0491 meter cube water for the producing 1 ton of cement, but nowadays it is reduced about 45%. And water consumption for the producing of this material for this cementitious product in the final stage, it is also drastically reduced down by 73%. So what is the important thing? We are recirculating the things, and JSW is one of the cement company which is having water positive units, and definitely we are giving the continuous recharging of groundwater to increase the groundwater so that we can recirculate it and use for the cement production. CO2, that is carbon dioxide emissions. Definitely there is a reluctancy from or opposition from the nearby areas wherever our plants are located. But nowadays there are the baghouse effects are there, and electrostatic precipitators are also there installed to capture the floating particles of GGBS as well as the cement particles, and again those are recirculated for manufacturing the cement. So you can see over here we are CO2 emission is also there, which is drastically reduced from 33%. We were having previously 443 kilogram of carbon dioxide, which is produced for producing a 1 ton of PSC. Nowadays it is about 296, so reduced down about 33%. We can have the comparative study over here. If the material is clinker or 100% OPC, for 100% OPC production, 769 kilogram of carbon dioxide is evolved in the environment. While producing the PPC, about 566 kilogram of carbon dioxide is evolved. And while producing PSC as well as GGBS, this is drastically reduced down about 429 to 65 kilogram. So as compared to the OPC, it is about 50% of carbon dioxide is evolved while processing the PSC manufacturing. So we can imply that CO2 emission in PSC is lower about 44% as compared to OPC, as well as 24% as compared to the PPC type of cement manufacturing. Eco-friendly product, we can see over here the CO2 certification, and for GGBS manufacturing, generally 52 kilograms of CO2 is evolved. This is one of the test certificate results are also there. We will see environmental impact of this whatever production of OPC as well as GGBS as well as fly ash. There is a huge climate change in the environment. You are watching over there. The CO2 is evolved because of that heat. Normal ambient temperatures also increase. So whenever 100% of OPC is there, so about 0.95 ton of CO2 is evolved, and energy is also much more, which is required to produce the OPC. But whenever I'm producing GGBS, this energy is drastically reduced down to 25% as compared to the OPC requirement. Then mineral extractions from the environment and the quarries. So for the OPC, it is about 1.5 tons, and in GGBS, it is negligible, is equals to 0. Water disposal, definitely we are recirculating the water for the manufacture of our PSC as well as GGBS, so less water is utilized. So these are the environmental impact from point of view for the production of OPC as well as GGBS and fly ash. And definitely there are the greenhouse effect. You generally we are discussing about CO2 emissions. So whenever I am using 100% OPC for manufacturing of concrete, about 142 kilogram of CO2 evolution is there. Whenever I am replacing this OPC 50% with the GGBS, then this is reduced about 60%, and about whenever I am replacing this about 30% of fly ash, it is 83%. Definitely use of the GGBS is much more beneficial as compared to the CO2 emission. Energy use. As compared to the OPC, the energy is for the GGBS, it is less, that is 71% only we are utilizing, and mineral extraction as a 92%. So this is the comparative studies and environmental impact for producing 1 ton of concrete. And you can see generally in India, M30 and M40 of concrete is generally mostly utilized in for infrastructure project and commonly used grade. So say for example, this is an example of M30 concrete. And if I am going to cast a concrete with GGBS plus OPC, OPC is 30% and GGBS about 70%, then this CO2 is about 139. And if I'm using 100% OPC with 0 GGBS, this CO2 emission is about 370. So you can compare between GGBS 70% replacement as well as GGBS 50% of replacement. About 50 to 25% reduction in carbon dioxide is observed. So definitely it helps for the environment point of view. So we can see GGBS is one of the product and mineral admixture which is helpful for sustainability as well as for the environmental safety. We can say it is an eco-friendly product. Definitely there is a pollution, air, water and land, and we want that free environment which ensures the no adverse impact on the health as well as the human bodies. Utilization of this GGBS and other byproducts, definitely we are minimizing the burden on the land, because previously before using in construction sector, these slag based products and GGBS we are using for the land filling purposes, but now it is used as for the concrete making. Definitely the burden on the lands are reduced down. The reduced virgin material also, because limestone we are preserving. There is a reservation, or there is a vast saving in the limestone in the environment. Reduce fossil oil also, because we are using alternative resources for the energies. And definitely use GHG, that is for the global warming point of view. We are reducing these emissions and direct contribution to reverse the effect of global warming, because this is a 21st century global question and problem in front of us. We can see some of the pioneer projects and the structures which are built with the replacement of OPC with GGBS. So partial replacement of a 40 or 60 or 50%. So we can see in India there is a Bhakra Nangal Dam which is on the north side of India. So that is also constructed with the replacement of OPC with GGBS. Then as far as abroad projects are concerned, this is one of the sea bridge, and this is a cable stay bridge, and that pillars and the piers are constructed with the GGBS admixture, this mineral admixtures replacement, and it is in Japan. Then the Norway also, there is national road concrete about up to M80 we can produce the concrete with the help of GGBS as OPC combination. As far as India is concerned, in Mumbai there is a Bandhavali ceiling project. Also we have produced about M60 high grade of concrete for piers, and this is the produced with the help of OPC plus GGBS combination. And this is from all of us. This is from umbrella of JSW company. We are having JSW PSC Portland Slag Cement, JSW GGBS, and we are having GBS, that is glass blast furnace slag is also there, which can be utilized as a 80 to 100% replacement while plastering. as well as in concrete. It gives a good strength and good abrasion resistance for the concrete. And we are having normal GGBS also. One can blend their OPC with GGBS to produce the concrete from M20 to M60 grade of concrete, and which does not only increases the compressive strength of the concrete, but also gives the durability point of view, the extended life of for your infrastructure and concrete. This is all from us regarding sir GGBS based products and our JSW cement. Thank you.
Thank you, Dr. Agarwal.
Thank you, madam. I request participants if they have any query or questions. So many good comments are there in the chat box.
Thank you.
Madhusudan Agarwal has raised a hand. Madhusudan?
Yes.
Madhusudan ji, please.
मैम एक्चुअली आई एम आस्किंग दैट आपने इसमें कॉस्ट कंपैरिजन नहीं बताया है. एक कॉस्ट कंपैरिजन एंड सेकंड थिंग इज that amount of GGBS is available as best so that we can replace wholly OPC with GGBS based cement. Means how much waste is available?
Right. So there are two questions. Number one is the cost and number two is the availability of GGBS.
Yes.
So when we are talking about cost, let me tell you, sir, the cost of GGBS is such, it is 3 rupees per kilo, approximately 2.75 to 3 rupees per kilo in Mumbai West region. And as far as your cost of concrete is concerned, the cost is competitive because whatever cost of concrete is there, you make with OPC fly ash, similar kind of cost you will get in OPC GGBS concrete for various grades. This is number one. Number two is the availability of GGBS. You can get as much quantity of GGBS as you want for west and you want for south. So in northern part of India, we do not have operation, but again, nevertheless, in Gurgaon, in certain projects, we have supplied GGBS. And even in East, if some specific requirement is there, depending on your requirement, we can supply the quantities. No worry on that. Percentage of replacement can be between 25 to 70%. That depends on your comfort zone. So just to tell you, Trans-Harbour Link, Mumbai Trans-Harbour Link, they have replaced GGBS up to 60% with their OPC, and they have also used microsilica to 5 to 10%, and they are getting very, very good result, which is again a construction which is deep inside sea.
Okay.
Madam, can you see the chat on Pawan Kumawat?
Yeah, GGBS is not pozzolanic, sir. GGBS is not only pozzolanic. GGBS is both hydraulic and pozzolanic. Why it is hydraulic? Because it has got a lot of calcium oxide in it, much more, 30 to 40%, much more as compared to fly ash. And fly ash is only pozzolanic, but GGBS is both hydraulic and pozzolanic in nature.
Pawan Kumawat is also there in chat box. Can you please check?
I am not seeing his question, sir.
He has written, what are the quality types of cements in the Jojila tunnel in north where temperature is very low?
What are the Jojila tunnel in north where temperature is... So where temperature is very low, we would suggest you to go for a rapid hardening cement or a cement which has got more higher, C3S content and high fineness. That is the type of cement which will be there. At coastal area where the corrosive environment is there, it is better to go for cement like slag cement. So slag cement which you are using has got very good chloride binding property. So that is very good for coast and desert area of Rajasthan. Desert area of Rajasthan, you can use any type of cement, but especially for Rajasthan, we would say you should also go for blended cement because the temperature is extremely high. In the daytime, there will be extreme heating, and in the nighttime, there will be extreme cooling. So there will be a differential stress buildup in the system between the day and the nighttime difference. There will be a lot of thermal stresses and shrinkage which will come. But if you take care of that and you use cement with mineral admixture like fly ash or GGBS, GGBS is not available in north currently, then you will have a structure which is shrinkage free and it will be good for your long run. Is if we are there in GGBS, then painting important? No. See, GGBS is a product which is whitish in nature. Calcium oxide parts say it is whitish in color, it is whitish in nature. So if any structure is utilized making GGBS, you will have a very good surface to paint upon. The urban heat island effect will also be less. That is, less heat will be generated from the building. The buildings are not going to absorb heat. Plus, it will also have a cooling or lowering effect. Can GGBS be used for lime-based product? GGBS itself is a lime-based product. So GGBS can be used in line along with OPC cement to bring in that initial reactivity, and it can be used with cement and it can be replaced up to 70%. Okay. Is it true that the poor curing of GGBS concrete more sensitive OPC or PPC? Sir, this OPC, there are the pros and cons of seeing it. Any structure should be minimum cured for 7 to 14 days. 28 days is extreme. But what happens only if OPC is there, and even if in an OPC structure you are not curing, the heat of hydration will be such, there will be a lot of shrinkage crack and thermal cracks which will come. However, if you are taking PPC and PSC and you are not curing it, that is also not desirable, because slag and everything, they start acting after 7 days. So any structure you make or any structure you build, it has to be cured, because everything has its pros and cons. Somewhere the heat of hydration will be more, somewhere it will be less. Somewhere again, there will be a delayed reaction of the slag which is going to start, or the fly ash which is going to start. So minimum 14 days curing is must. How much percentage of fly ash addition in making into cement? Sir, it is as per IS code 15 to 35. Many of the cement manufacturers are in the range of 33 to 35%. What happened if we partially replace PPC with GGBS? So now we are talking about triple blend. Triple blend is standard blend where you have a combination of OPC, you have a combination of GGBS, you have a combination of fly ash. You can also use microsilica, or you can use alcofine, which is a ultra fine ground GGBS. I think I have answered all the questions.
Yes, yes, madam, you have rightly answered, and technically champion answered all the pertinent questions, and definitely, as Dr. Hegde has rightly written, that JSW cement is the pioneer and is the name in the country for the slag cement, PSC, as well as fine aggregate after 383 has mandated it. So we were very fortunate to have you and Sawantji for today's sessions.
The pleasure is all mine, sir. I really wish we can also in fact keep on, giving lectures to your students in future whenever you have classes. So we will be very happy to do that. We have got state-of-art concrete laboratories, which we are having here in Dolvi, in Shalboni, in Calcutta, and in South in Hyderabad. So there we do a lot of mixed design, durability test, and we also run a lot of workshops. So you can be a part of that, and we can take your students to that process.
We shall be grateful. Professor Dr. Hegde wished to say something. I think he has raised a hand.
Right, sir.
Okay.
Yeah, good afternoon, Lopamudra.
Good afternoon, sir. How are you?
I am fine. Excellent lecture. I congratulate both of you.
Thank you, sir.
And I got one suggestion. Whenever you are presenting the data with GGBS and OPC and composite blends, it will be desirable if you can show the heat of hydration, so that it will be very important for all the civil engineers to find out the thermal gradient.
Then he understood, sir. We in fact have a detailed module presentation, like we have done our PSC cement tested, that has got given 232 units of heat of hydration, and that has given 800. Because the time is short, we could have taken you through all the heat of hydration. We have done many mock-ups here in West. And like India Bull, Sky One, and all that, all mock-up data are there, and what is the heat of hydration, how we have done it, the thermal, the chilling plants which we have installed, everything is there. Only thing is that, that again goes too much into concrete. So the topic was relevant today, and on need basis, we can do an entire session on this geological properties and the performance parameters of the concrete as per the need.
Okay, thank you.
Thank you, sir. How are you, sir, by the way?
I am good, doing well.
अभी कहाँ पे हैं?
I am in Udaipur. I am with JK Lakshmi Cement.
Very good, sir.
You
Very
might
good.
have seen that Professor Agrawal has sent the invitation. It is
नहीं, मैं तो
mentioned
आपको
there.
LinkedIn में follow करती हूँ ज़्यादा.
हाँ जी?
LinkedIn में.
Okay, thank you. Thank you.
Thank you, sir.
All the best.
Dr. Hegde has shared that you had been for a long time associated with the Grasim Industries as well. So,
Yeah, I know him. Okay, but one last question. So he is asking, what are the different nanoparticles in the cement industry reduce the heat absorption for urban area? Heat absorption urban area के लिए तो sir slag ही है. Nanoparticles आप जितना मर्जी उसको fine करते जाओ, too much fineness is also not desirable because it will create fine. It is going to increase the cost. Secondly, it will make the concrete uneconomic. Third is it may lead to cracks, bleed water ऊपर आपका चला जाएगा. So nanoparticles, GGBS itself part से बहुत fine grind करते हैं. You can use that. Fly ash is also good, but fly ash has its own, it has it. I would say it has its own beauty. Unique beauty. Unlike GGBS, which is having all-round beauty.
Right.
Lopamudra, I understand you are pursuing for PhD degree from IIT Kharagpur, right?
Right, sir.
What is the topic of that? May I know that?
Sir, मैं आपको individually बताऊं, not in the area.
Okay.
Give me your mobile number.
Okay, sure.
I will drop you an email. I have your LinkedIn. I will drop you there.
Thank you. All the best.
I will drop you. Sure. Thank you, sir. Okay. Thank you, sir.
thank you, madam, and thank you, Mr. Sawant for sharing rich knowledge and rather treasure of knowledge in field of slag and slag cements. I am grateful, and we definitely look forward to your suggestions for benefit of our students. Thank you, madam. Thank you, Sawant.
Thank you, sir. Namaskar. Thank you. See you. Bye, sir.
Thank you all. Yeah.
Thank you.
Bye.
So there's an announcement for the participants. We have mailed the link for tomorrow's sessions, 3 sessions. I think most of you might have received the mail. So please attend the 3 sessions tomorrow. We shall be sending the link for feedback, etc. also. As in the morning, the director IIT Guwahati had suggested one session on yoga is also being organized through Art of Living. So I had a talk with the state coordinator of Rajasthan state for that. So he has kindly agreed. Once the time gets finalized, we shall let you know. So the one extra session than what has already been circulated to you. So I think you will relish that session and you will like that session. So thank you, Dr. Hegde sir.
Thank you, sir.